Good afternoon, everyone. I'd like today to talk about another side of Go, that being programming pictures. We know that Go is great on the back end. We all have heard of its exploits. It's been called the emerging language of cloud infrastructure. But you know, sometimes it's about the picture. And that's what we're going to talk about today. We're going to talk about design. We're going to talk about the design of APIs and client programs that use them. We're going to get a little bit into visual design and relationships and why Go. My journey will be through 3 Go packages that illustrate these points. Let's start our journey with SVG Go. SVG Go does one thing. It creates and sends to an I/O writer scalable vector graphics, the 2D standard for graphics on the web. It's built around trying to follow what the standard does. So you've got one function for any kind of element for SVG. So you think in terms of rectangles and circles and lines and so forth. This is what its API looks like. So you've got a function that corresponds to an SVG element, and you've got some typical arguments that talk about where it is on the canvas and how big it is. If you don't give it anything else, you get the unstyled version, and there's the XML version in the middle. If you drop some CSS on there, then you can change and you can style your object. Again, using variadic arguments to do this. Sometimes you just need to put in specific attributes, and you can do that as well. Again, thank you, variadic arguments. Here's the hello world for SVG Go. As you can see, you start with some dimensions, and you start with the canvas, and you're going to specify where you're going to spray your stuff. Where are you going to put it? An I/O writer. If you look at the picture, it's made up of 3 elements, a rectangle, a circle, and some text. Between the start and the end, you've got functions for, guess what? A rectangle, a circle, and some text. Tries to be straightforward that way. This is Bugdroid. You all know him as the cute Android mascot. But when I see Bugdroid, I see that what he's made up of. He's made up of lines and rectangles and arcs and circles with different colors that you can scale. Once you have this idea in your head that you can program the elements of graphical elements, you got superpowers. Anything that you can do with something like Adobe Illustrator or those kinds of tools, now you can program that. And you can program it using the full power of the language. Because SVG Go writes to an I/O writer, it's just as home on a web server as it is with command line tools. Here's a little web server that draws a circle. If you say / whatever, you can style it differently. I've taken this idea with a little picture server that I wrote at this particular URL that explores what can I do in a 256 by 256 box. And some of the things do the obvious thing. The clock does the thing that you would expect. You can change some of the parameters with randomness and so forth. You can make the smile into a frown and so forth. Again, I wanted to see, now that I've got pictures, how can I serve them up and have people play with them and be useful? So for example, you can make Pac-Man, you can change the angle of his bite just by specifying some arguments to the URL. I want to talk about something that I discovered when I was creating clients for SVG Go, and that's what I call the read, parse, draw pattern. And Go really makes this wonderful to be able to do this. It's all about, as we said before, turning data into a picture. And the data can come from anywhere. Your files, the network, somebody's API, but you need to be able to visualize things. Here's a program broken up into its components, but the ones that I want, and these are familiar to you, but the ones I want to talk to about is starting from the data structures described in structs. Then, because you've got things like the encoding package, you can turn those structs into objects in memory, then you can draw them. Again, superpowers. Start from the data, decode them, boom, make your picture. Let's go through some of the examples. So this is a simple example of a bar chart and its XML representation. Let's go through a whirlwind tour of some SVG Go clients. Here's one that visualizes Go benchmark. One of the talks talked about bench compare. This takes the output from bench compare and turns it into a picture. Things like standard bullet graphs. This particular chart was one of the early examples of SVG Go because I was drawing these all the time with graphical tools. And I got very frustrated. I said, you know what? I can program this easier than I can push pixels around. So therefore, I can start with a standard representation and evolve the picture as I need to. This is one that putting things in quadrants. If you're in enterprise or other kinds of things, they love putting things in quadrants. And we use these, for example, for evaluating projects and where they should land. Similarly, we've got these kind of roadmaps that we do a lot. This one is a different kind of version of that in that you can look at things in 3 dimensions: time, impact, as well as effort. But from the same kind of data, you can look at it linearly as well as radially from the same data. Server layouts, conventional plotting. This is a visualization of Twitter update frequency. You give it a keyword, and you take the top 10 tweets, and you can see how many times people have tweeted on that particular thing over a particular period of time. And an exploration of scale. This is one of my favorites. How many have heard of layer tennis, right? Layer tennis is a contest put on by Adobe that pits one designer against the other. They start with a picture, and they volley it over to the opponent, back and forth and back and forth, and a winner is declared. These are 3 layer tennis matches laid out, so that you can see them and understand and visualize how the match went. This is the full season 4 of layer tennis, culminating with a championship round with the gold at the bottom. Sometimes you want to compose and work with other people's APIs, like the Flickr API. SVG Go comes with a program called F50, standing for Flickr 50. You give it a keyword, it talks to the Flickr API and gives you a nice poster ordered by Flickr Interestingness. Uses the exact same pattern. You're reading from the network, you get an XML representation, you turn it into a picture. These are the shot charts for the top 10 scores of the NBA. Thank you, LeBron. Now, here's one thing that I really love about SVG Go. It comes with a little local playground that allows you to have your code and your picture together simultaneously. And you can tweak your code and see your result immediately. This example is showing tweaking the TI variable, and you can see the different versions of what you got. This is very, very powerful if you want to understand and try out different things. And then when you're done, you've got a working Go program. Very nice for figuring out what your design should look like. I'd love to be able to demo this later. The next one I want to talk about, package, is OpenVG on the Raspberry Pi. Everybody knows that Go runs very well on these little computers. And what I wanted to be able to do was get access to its GPU, because the standard software that came with it didn't allow me that. And I wanted to program at, again, this higher level in terms of circles and ellipses and so forth. So first I created a C library that wrapped the OpenVG API. Then I have a Go companion for that. Here's some examples of what you can get from that. And here's the hello world for OpenVG. As you can see, it's similar. You have a start and an end, and you've got your elements with circles and text and so forth. This one's slightly different. Instead of having variadic arguments, you have discrete functions that style your code, because that sort of fit with the underlying API. Here's what some of the functions look like. You can sort of see some similarities here. You wanted to program at this particular level, the level that an artist or designer would think about when they're manipulating these things. The last package I want to talk to you is Deck. Guess what? You're watching Deck right now. It's a Go package for presentations, and it was one of the first clients for OpenVG, but now we've got clients for SVG and PDF as well. It uses that very same kind of idea in that you've got a standard representation for your document, in this case slides. You've got decks, and within a deck you've got slides and elements for things like images and text and lists and so forth. This particular markup makes that slide. When I was putting this together, I was thinking about how am I going to do layout? So I said, you know what, let's keep it very simple, and we're going to do everything on a percent grid. That way I don't have to worry about dimensions and so forth. Let it scale. I wanted to see how far I could take this idea. Again, when I'm creating these kinds of APIs, I only do the minimum for the kinds of things that I want to do. I only add things when I need them. Here's an example of laying things out on that grid, 3 elements. And as I said before, it has the nice property, if you just change the dimensions of your canvas, things will scale automatically. Some people like to write XML code by hand, like an animal, but sometimes you need some other kind of process to create that code for you so that you can have one representation of your deck and you can have the interactive version, PDF or an SVG. For that, I've got a package called deck/generate, which again has the similar kind of functions as you can see for text and code and lists, images, and graphical elements. Here's an example of a program that makes 3 slides. Just like SVG Go, it writes to an I/O writer. You start your slide and you end your slide and you have your stuff in between. Blowing that up, this is what a particular slide looks like. So as you can see, I'm styling the background with RGB. You can use RGB or you can use named colors as well. And then you've got your textual elements and then a line in between. Here you're looking at using a string slice to represent your lists. And the ever popular hero picture with some text on top of it. I like this particular style of presentation. But sometimes when you get your design set up, you want to be able to codify that and use a simpler representation. So I've got a program called CapGen which uses caption slides. And you can see the simple representation with a title and a section and a caption automatically will generate the code to make these slides for you. So you're not, again, fiddling with the thing, you're letting the program do it for you. By the way, Deck also has a web API, so you can plug like a Raspberry Pi or something into a remote display and then control it via that way. Let's go through some design examples. Usually when you're doing layouts, you think in terms of, okay, where am I going to put my content? Top and the bottom, left and the right. Then because Deck lets you do things in percentages, what are the proportions I'm going to use? Then you think semantically, a header and a footer and a summary and a detail. Here's a slide that uses that design. Here's yet another one. And another. One of the things I figured out when I was putting this together is this could be great for things like digital signage because you've got a great mechanism for mixing text and graphics in a very flexible way. This was taken from a Google Glass example. This is grabbing data from a finance API. Another way to look at Go documentation. A nod to Rene Magritte. Putting things in grids, another way to look at that. Or how do I show some interesting text from a blog post? Or finally, classical poetry. And then finally, the 10 Principles of Design by Dieter Rams. But what is it about Go that makes this work, at least for me? Simple things like the Thump package make generating code trivial. Very, very nice. My favorite keyword is funked. Because then I can encapsulate my design into functions that I can call and use and understand the relationships. This is a very, very powerful method for me. I/O Writer and I/O Reader are perfect, a beautiful thing, a thing of beauty. I can spray my SVG anywhere. I can consume and produce APIs with things like the NetHTTP package. And as well as the encoding XML and JSON package are great for that too. For, again, moving your data in, getting it into your struct, boom, make your picture. Seago make things like OpenVG work. And importantly, there's the community. I'm indebted to folks who do things like make Go run well on a Raspberry Pi, or generate PDF, or do things like the GIFT program that allow you to manipulate images. But one thing I want to point out to you, early on when I was experimenting with SVG Go, I received this email from Russ Cox on March 5th, 2010. He said, "Are you going to share the libraries or just tease us with pictures?" That was just the impetus that I needed, and I appreciate that from him, to be able to give just the push to make a library that worked for me, but other people might be able to use as well. And as I was thinking about this, how it worked for me, I would remember this particular quote where Dennis Ritchie is describing how Ken Thompson came to design Unix, where he said Thompson wanted to create a comfortable computing environment constructed according to his own design, using whatever means were available. This is echoed again from Rob Pike when he was describing the origin of Go's interface design. Go is not the product of a Whiggish development process. We were just trying to get something that worked for us. And to me, it's all about tools. I didn't like the way some of the tools worked, but I'm a programmer and I can make things work the way that I wanted to, just like the giants before me. And you know what? It's a lot of fun. Being able to see and realize your design immediately is a blast. To me, it's all about reducing the distance from the idea to the picture. And I want to leave you with a note from these two guys, Pablo Picasso and Alan Turing, who represent to me the art and the code. And I'd love to have you be inspired to combine these two together to program pictures. Thank you very much.